question 5. Question 5 again is a type of question where it asks you some things and then it says which one of the following statements is false concerning waves. So this time we have to pick the false one. A, their amplitude is a measure of their volume and strength. B, they transfer energy and matter from point A to point B. C, sound is an example of a longitudinal wave. D, a standing wave is the result of the combination of an incident and reflected wave. Okay, so which of the following is false? Now some of these things I've covered in the previous videos that I just did, so we're not going to have to go through and explain them. A, their amplitude is a measure of their volume and strength. That's true. I explained about that. The bigger the amplitude, the more volume it carries and the more strong the wave is, right? So that's true. B, they transfer energy and matter from point A to point B. So if this is point A and a wave is coming this way, right? And then let's say this is point B. Does the wave actually carry energy from point A to point B, right? Let's say this happened to be like an ocean wave and there was something in the ocean like a bucket or something or a can and then there was another can over here. So what would happen to those cans? Well, actually this question should be split up into two parts. They transfer energy from point A to point B, and do they transfer matter from point A to point B, right? So what's going to happen here? Well, does the ocean wave actually transfer energy? So as the wave is coming, does it do anything to these cans? Well, we know, of course, they do. The can is going to actually go up and down. An ocean wave actually turns out to be kind of a combination of a transverse wave and a longitudinal wave. So what the can's motion is almost going to look like circular, like this. It's going to go up and down, and it's going to go this way, right? So it's going to be a circular kind of motion. This can, same thing, circular kind of motion. So we know the ocean wave has to carry energy because it's making the can up and down. We also know it's going to carry energy because if we happen to be in the path of that ocean wave, the ocean crashes into us, it carries energy. We also know that waves carry energy just by simply looking at the sun. The sun carries energy towards us in the form of electromagnetic waves, infrared waves, light waves, all of those kinds of things. So definitely waves do carry energy from point A to point B, and that energy is transferred through the propagation of the wave. Now, second part, do they actually transfer matter from point A to point B? Is this can gonna literally go all the way to there, and then that can gonna go all the way there, right? Is the can gonna go from one point to the second point? The answer is no. Waves do not transfer matter from a point A to point B, right? The energy is transferred, but the matter goes either up and down, or it could go sideways, or it could go in a little circular motion, okay? So the second part of that question is false, therefore this is the answer, B. They do not transfer matter from point A to B. C. Choice C says sound is an example of a longitudinal wave. We already covered that a couple of videos ago, so that is a true statement. And then D says a standing wave is the result of the combination of an incident and reflected wave. Well, that is actually true. So if a wave, if you get a string here and you tie it to the wall, right, and you start shaking it, right, the wave is going. Now, if the wall wasn't there, the wave would just simply go, propagate like that, and you don't really have any kind of standing wave. It would just go forever, right? But if it hits here, so this is incident. This is an incident wave, right? So the wave is traveling right now, and it's incident upon the wall, right? And then it reflects from the wall. reflection. So when you have incidence and when you have reflection, you have two waves that are going opposite directions, right? You have the wave that you're sending over here, you have the wave that's coming. When the two waves interfere, they start to create standing waves, okay? So standing waves. Now, either they're gonna kill each other or they're gonna enhance each other, and then there are certain frequencies where you get nice resonance, right? And then those are the harmonics that we talked about in the previous videos, right? Your fundamental frequency, second harmonic, third harmonic, and so on and so on. So if you vibrate the string with a certain specific frequency, then those waves, the forward wave and the back wave, will enhance each other and will create nice harmonics, okay? So definitely it is true, a standing wave is the result of the combination of incident and reflected. That's true. So this is the false statement, okay? Thank you.